Welcome back, everybody. We are up to lesson 4. We're just continuing on learning about important information about polynomials. Off to the left here are some stuff about adding, subtracting, and multiplying polynomials. So when we add polynomials, really the name of the game is that we combine like terms. Okay, what makes a term like? Like terms mean same variable and same exponent. So two terms are considered like if they have the same variable and the same exponent. Okay. And we always start with our highest exponent between them and work our way down. And if we don't have any like terms, we bring them down. So that's adding polynomials. Subtracting polynomials, we use this moniker keep, change, change. So keep, change means keep the first one the same, change subtraction to addition, and change all of the signs in the second one. So changing signs mean if the term is positive, switch it to negative. If the term is negative, switch it to positive. Okay. Essentially, when we subtract polynomials, we're going to follow the same steps as we're going to change it to an addition problem so that we can follow the same steps as addition. Okay. Multiplying polynomials, we're going to use the box method or the distributive property. So the box method or the distributive property. So some of you may have learned the concept called FOIL, but the FOIL method is basically the box method or the distributive property. So that's how we multiply polynomials. Last thing I want to address in the lesson notes is what constitutes a polynomial. Like if I have a mathematical expression, how do I know if it's a polynomial or not? Well, we've talked about this before. A polynomial has to have more than one term. Poly means many, so that's an obvious characteristic, okay? But these are the other important characteristics of a polynomial. So all the terms are either constant. So remember, a constant term is a term that doesn't have a variable, or they contain the same single variable. So all the terms have either x in them or they're constant terms. If you have a expression that has more than one variable in it, it's not a polynomial. It's in a mathematical expression, but it's not a polynomial. Okay. The other important is all variables. So any term that has a variable in it, all variables are raised to non-negative integer powers. So if you look at all the exponents of the variables, they have to be non-negative. So non-negative means 0 or higher. And they have to be integers. Integers meaning whole numbers. So no fractional exponents, no decimals, no negative exponents. So if you have a mathematical expression that contains a term that has a fraction or a decimal or a negative exponent, if it contains any of that, it's not a polynomial. It's a mathematical expression, but it's not a polynomial. So again, all terms are either constant or they contain the same single variable. Okay? No multiple variables. And all variables are raised to non-negative integer powers, meaning no fractions, decimals, or negative exponents. Okay? So with all this in mind, let's take a look at the examples here. So if you add or subtract two polynomials, will you always get a polynomial? If you multiply two polynomials, will you always get a polynomial? Try combining some polynomials to answer your question. Use the ones given by your teacher or make up your own, and keep a record of what polynomials you tried and the results. When you think you have an answer to your question, explain your reasoning using equations, graphs, visuals, calculations, words, or in any way that will help others understand your reasons. So what I would like you all to do is to make up your own polynomials like I'm going to do right now. So I'm going to just make up two polynomials. So let's say, let's see, x squared plus 3x minus 2. And so there's one polynomial. And 3x minus 7. Okay. So notice both of these would be considered polynomials because notice there's not multiple variables. Okay. So all the terms are either constant or they contain the same variable, x. Okay. And all of the exponents are positive, non-negative whole numbers. Okay. So these are our polynomials. So let's answer number 1. Let's add these together. Okay. So when I look at these two polynomials, okay, when I look at the highest exponent between them, the highest exponent between them I see, and I'm going to use a different color here, is x squared. Now notice there's no other x squared term to combine it with. So I'm just going to bring it down. Okay. Back in the lesson notes, that is what I meant by if there's no like terms, bring it down. Okay. And then we're going to work our way down. So I have 3x and positive 3x. So positive 3x and positive 3x is going to be a positive 6x. And then negative 2 and negative 7 is going to combine to negative 9. So when I add these together, I get x squared plus 6x minus 9. Okay. Now, let's take these same two polynomials and subtract them. So x squared plus 3x minus 2 minus 3x minus 7. Okay. So back in the lesson notes, it says we're going to use keep, change, change. So keep, change, change means keep the first one the same, change subtraction to addition, and change all signs in the second one. So 3x changes to negative 3x, and minus 7 changes to plus 7. So this is going to change to plus 7. Once I do that, I'm going to treat it like it's an addition problem. So I'm going to start at x squared, nothing to combine it with, so I'll bring it down. Next, I have 3x and negative 3x. But what's interesting about that? 3x and negative 3x becomes 0x, so that's actually going to cancel out. Okay? And then negative 2 and positive 7 is going to become positive 5. So I end up with an answer of x squared plus 5. Okay? Now the question is, when I took these two polynomials and I added them and then I subtracted them, did I end up with answers that were also polynomials? So do my answers only have one variable terms or constant terms? Yes. Do the exponents on the variables in my two answers, are they non-negative whole numbers? Are the exponents non-negative whole numbers? Yes, they are. So these are both polynomials. So to answer this question, if you were to add or subtract two polynomials, will you always get a polynomial? So can we think of a situation where if I have two things that I know are polynomials and I add them or subtract them, can I think of a situation where I would get an answer that is not a polynomial? And you can think as hard as you want, and it's never going to work. So will you always get a polynomial? Yes, you will. Okay. Now, number two, if you multiply two polynomials, will you always get a polynomial? So now I'm going to take these two polynomials I have, x squared plus 3x minus 2 and 3x minus 7, and now I am going to multiply them. So x squared plus 3x minus 2 times 3x minus 7. All right. So when I wrote this in the lesson notes, or when I talked about this in the lesson notes, we talked about that we're going to use the box method to multiply this out. So I'm going to set this up here. So I have x squared plus 3x minus 2, and I have 3x minus 7. And now I'm going to multiply this out. So we're going to start up here. So x squared times 3x, x squared times 3x is going to be 3x cubed. Whenever I multiply, I add the exponents on the variables. So this is x to the power of 1. So x squared times x is x cubed, and then I carry on that 3 here. Okay, over here, this is going to be negative 7 times x squared. So that's going to be a negative 7x squared. Okay, over here, I have 3x times 3x. So 3x times 3x. So 3 times 3 is 9. And x times x is x squared. This one right here is going to be negative 7 times 3x. So that's a negative 21x. Here I have negative 2 times 3x. So that's going to be a negative 6x. And then the last one here is going to be negative 2 times negative 7. That's a negative times a negative, so that's going to be a positive 14. So remember, with the box method, when I write out the answer, okay, I'm going to start up here. So my answer is going to be 3x cubed. And then if I look along the diagonals will give me the like terms I need to combine. So I have negative 7 and positive 9x squared. That's going to become a positive 2x squared. I have negative 21 and negative 6x. So that's going to be a negative 27x. And then plus 14. So when I multiply these two polynomials together, I end up with an answer of 3x cubed plus 2x squared minus 27x plus 14. The question is this a polynomial? Does it have single variable terms or constant terms? Yes. There aren't multiple variables here. And 3 of the terms have variables in it. Are the exponents on the variables non-negative whole numbers? Non-negative whole numbers. Well, I have cubed, squared, and then x to the first. Those are all positive whole numbers. So this right here is also a polynomial. Okay? So again, to answer this question, if I take two things that I know are polynomials, that I know satisfy the requirements to make it a polynomial, and I multiply them together, will I ever get an answer that is not a polynomial? So will I ever get an answer that has multiple variables in it? Obviously not. Okay? Will I ever get an answer? Will I ever get an answer that has negative exponents if I started out with only positive exponents? No. So to answer the question, if you multiply two polynomials, will you always get a polynomial? The answer is yes, you will. So that is it for this lesson.